completing the square, solving quadratic equations by completing the square. So completing the square as we go through it, again, I know I say this a lot, if some things kind of seem like review, this was covered in Algebra 1. But what we're going to be going through first, the first two examples is actually not completing the square, but it's solving quadratic equations by using the square root property, which actually was a problem or something we covered before your quiz. It was on your quiz, using the square root property. This is just going to look a little different with how it's set up, but it is setting us up as to why we complete the square. So not just knowing how to complete the square, but why you're even doing it. So square root property, just as a review, is say I had an equation x squared equals 4. So this is just a simple example. So it's where you didn't have an x term. It was just x squared, and then it was a constant term. So we got the x squared alone, so that to solve for x, we could divide or take the square root of each side. And that would leave us with just x equals, when you take the square root of 4, you have plus or minus, and then it's 2, since 4 is a perfect square. And it is plus or minus because positive 2 squared is 4, negative 2 squared is also 4. So the idea is you have something that's a perfect square on the left side that you can then take the square root of to get x alone. So that's the same idea with 1 and 2, but we will not just have x squared on the left side, because if you look at both examples, you do have an x term. So if I wanted to get x squared alone, I'm still going to have x on the other side. So it doesn't make sense to use it the exact same way we did before. So the way I'm going to have you work through example 1 is you're going to start out not rearranging anything. You're going to leave the equation exactly the way that it is, and we are going to factor the left side. So I know typically when you factor, you get one side equal to 0. We're not going to in this case. You'll see why. So we're going to factor x squared plus 14x plus 49. So for a trinomial, we can set up our diamond. And in that trinomial, so I'm going to ignore the 64 right now, what number are we multiplying to? 49. And we're adding to what number? 14. Okay, so what two numbers multiply to positive 49 and add to positive 14? 7 and 7. So because there is a 1 in front of the x squared, you could rewrite this by splitting the middle term and then factor by grouping. But when there's a 1 as your a value, you don't have to do that. The factored form of this would be x plus 7 times x plus 7. I still have the equals 64. But because both factors are the same, I can write this as x plus 7 quantity squared equals 64. Okay, now the reason that works out, so we're not finished with this yet, but I'm going to kind of do a side note here. When we were reviewing how to factor trinomials, I did mention there's a special type of trinomial, and that's the perfect square trinomial. So I'm just going to rewrite the trinomial we had, which was x squared plus 14x plus 49. And here's how to recognize if you have a perfect square trinomial. So again, it's if the very first term and the very last term are both perfect squares. So x squared is a perfect square, the square root is x. 49 is a perfect square, the square root is 7. And then your middle term needs to be 2 times the product of these square roots. So the product of these square roots is x times 7, so 7x. And if I double that or multiply it by 2, I do get 14x. So therefore, if you have a perfect square trinomial, the shortcut then was to say this is going to factor to be a quantity squared. Since it is a perfect square trinomial, the quantity inside in this case would be x plus 7. So you have your 2 square roots, the x and the 7. It's positive because the middle term is positive. If this middle term was negative, we would have x minus 7. So there's two different ways you can get to this factored form. Diamond still works. The reason it's factoring this way, though, is because this is a perfect square trinomial. So thinking ahead, when we start completing the square, we want the trinomial we have to be a perfect square trinomial so that when we factor it, it's one quantity squared. That's thinking as to why we're doing it. Once you're here, just like how we used our square root property before, this is a perfect square, and the only way to solve for x is to get rid of this exponent of 2, meaning we have to take the square root of both sides. So that'll cancel out that power of 2 on the left side, and you'll just be left with x plus 7. And then when I take the square root of 64, it is a perfect square, so I get plus or minus 8. And then to finish solving for x, I would subtract 7 from each side. But I want you to make a note that you have two answers, and this here does not become plus or minus 1. You do not subtract the 8 and the 7, because what this actually represents is one solution is going to be negative 7 plus 8. The other solution is negative 7 minus 8. So notice one of the 8's in the solution is positive, one's negative. That's where the plus and minus comes from. So one of your solutions is positive 1, the other is negative 15. And those are the two answers for example 1. So we're going to also look at example 2, but again, the idea behind this is you start out with a perfect square trinomial so that you can factor it to be one quantity squared. That allows you then to use the square root property, take the square root of both sides to solve for x. So the perfect square trinomial is key. So if we look at example 2, the solution for this one works out a little differently. So that's why I want to go through it together. So I'm not going to set up a diamond for this one. If you wanted to, if that's easier for you to understand on your notes, that's fine. I want to show you, though, the perfect square trinomial method. So I notice, again, I'm not rearranging anything. In x squared minus 6x plus 9, the x squared is a perfect square. The square root is x. The 9 is a perfect square. The square root is 3. And if I multiply the two square roots, which would be 3x, and I double it, so multiply it by 2, I do get 6x. Now the fact that this is minus 6x, the minus is just going to be part of the factored form. So this is going to factor to be x minus 3 quantity squared, because it's a perfect square trinomial. So if you did set up a diamond, you'd be multiplying to positive 9 and adding to negative 6. Your two numbers would be negative 3 and negative 3. So the diamond does still work. And then I have equals 32. Once I have a perfect square or a quantity squared on the left side, I can use the square root property, square root both sides. So I get x minus 3 equals, I still have plus or minus, but 32 is not a perfect square. So now you have to think back to what we did in 4.4. I do not want you to type this in your calculator and give me a decimal. I want you to leave your answers in exact form, which means you're still going to have a square root in your answer. So this is where you have to think, is there a perfect square that goes into 32? Since 32 isn't a perfect square. 16 does. 16 times what? Times 2. So I can break that into the square root of 16 times the square root of 2. And the square root of 16 is 4. So I have plus or minus 4 square root 2. And I'd leave it that way, not write a decimal. And then I still need to solve for x, so I need to add 3 to both sides. But the 3 is not added to the 4, and it's not added to the 2. So I can write my answer a couple different ways. I can put the positive 3 in front and write it as 3 and then plus or minus 4 square root 2. You could write it as the other way around, x equals plus or minus 4 square root 2 with plus 3 at the end. Or if you really wanted to write it as two separate answers, you could write it in either of these forms, but one answer would be 3 plus 4 square root 2, and the other would be 3 minus 4 square root 2, if you actually wanted to split it into your two answers. But you can write both answers together using that plus or minus symbol. So this would be a fine way to write it, as would, this, or splitting it into two. But you need to leave it as exact, so I don't want you to type anything in your calculator and give me a decimal approximation. Okay, any questions on 1 or 2? Okay, I know I'm stressing this a lot. Don't just know what to do, know why you're doing it. So again, perfect square trinomial so that we can factor into a quantity squared to use the square root property. So how this ties into actually completing the square is every quadratic equation can be solved this way. And that's by manipulating the equation until one side is a perfect square. So that means if you don't have a perfect square trinomial, you make one. You make your trinomial a perfect square trinomial. That's what completing the square does. So I have these two examples are actually the two examples from 1 and 2 that we just did. So the idea behind this is what you're going to be doing with completing the square, is you are going to be given part of a trinomial. You're going to be given the x squared plus bx part of it, but you're not going to be given the c value, the constant value. You are going to have to find what value of c makes this a perfect square trinomial. So to find the value of c that should go there, there's a method to do it. You start out and you take your b value, which in this case is 14. You divide it by 2, and you square it. So 14 divided by 2 is 7. 7 squared is 49. So this c value that makes it a perfect square trinomial is 49. And if you look back at example 1, that is the trinomial that we had, x squared plus 14x plus 49. Okay, so you're going to be going through that process to do that. That is called completing the square. Then I also want to point out, when we factored this in example 1, the factored form was x plus 7 quantity squared. So I've already shown you two different ways you can factor it. You can still use a diamond because it's a trinomial. You can use the method of having a perfect square trinomial and factor it that way. When you complete the square, you already know that it is a perfect square trinomial. You don't have to check that it is. You are making it one. So rather than checking it, an easier way then to factor, a shortcut way, is it's always going to be a quantity squared. And this number, in this case, the plus 7, is whatever your b divided by 2 was. So here our b divided by 2, 14 divided by 2 is positive 7. So the positive 7 goes in our factored form. And that will always be the case. The 7 is also the square root of 49. And the positive is from the positive middle term. But there's multiple ways to get to that factored point. So if we look at the next one as well, this is from example 2, x squared minus 6x. So we know if we look at example 2, it should be 9, but I'm going to show you why it's 9. If you take your b value of negative 6 divided by 2 and then square it, negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. So that's why the c value is positive 9 in the perfect square trinomial. And then the factored form, when we factored this in example 2, it was x minus 3 quantity squared. So again, just to point this out to you, the minus 3 in the factored form is the minus 3 from your b divided by 2. b divided by 2 is negative 3, therefore the factored form is x minus 3, or x plus negative 3. Okay, so we are going to be completing the square a lot, not just throughout the rest of this chapter. And I know this is going to seem far away, but chapter 9, we complete the square in almost every single lesson. So it's really important that you understand how to do it. Otherwise, it's just going to make chapter 9 that much more difficult if you're not sure how to complete the square. So don't think we do it in this chapter and we're done. We still use it. Like most things in math, it's used later on. So this just lays out what I just talked about for completing the square, but it gives more of a formula to it. So if you have any quadratic expression of the form x squared plus bx, these 3 steps, your first step is to find your c value. I'm going to combine these first 2 steps. Finding 1/2 of b and then squaring it is the b divided by 2 squared that I talked about. That value then gets added onto your trinomial as your c value. And then when you factor it, again, whatever your b divided by 2 was is the value that goes in your factored form. So it's always going to be a quantity squared, and it's x plus whatever b divided by 2 is. Okay, so we're going to go through and practice this and put it all together with solving by completing the square. All right, so example 3 is just practicing completing the square and then factoring. So it says find the value of c that makes each trinomial a perfect square, and then write the trinomial as a perfect square, which means to factor it. So what quantity squared do you have? So if we look at a, we have x squared plus 12x plus c. So to find c, we take our b value, which is 12, divide it by 2, and square it. So that would be 6 squared, which is 36. Okay, so our c value is 36. And then to factor this, so if we have x squared plus 12x plus 36, I want you then to also write the factored form. So we know this is going to factor to be a quantity squared. What quantity would go in the parentheses here? X plus 6. So the plus 6, your b divided by 2 is positive 6. The plus 6 goes in your factored form. Right? It saves you a lot of time not having to do a diamond every single time. Okay, so I want you to do part B. X squared minus 5x plus c. Also, sometimes you'll have decimals or fractions. That's okay, as long as you are still finding c and factoring it correctly. I will walk around and check and answer questions. Just want to give you a chance to answer it first. All right. Here's B. I think we're all okay, but I know some of you, especially at the beginning, if you were still finishing up, double check. May I have your attention back up here, please? Couple of things. A lot of you had decimals written down, which is fine. Remember, my rule still applies. If the fraction is a repeating decimal, you have to leave it as a fraction. So there will be sometimes you need to leave the fractions there. So I do have the fraction answers as well as the decimal answers because the decimals would be fine in this case. Getting in then to examples 4, 5, and 6. I know some of you were looking ahead and wanted to start trying these, which is great. But you are solving these by completing the square. Okay, so you have to pay attention to the directions. You have to understand what the directions mean. I realize all three of these already give you a trinomial. However, for number 4, x squared is a perfect square is 12. No, so this is not a perfect squared trinomial. So when you complete the square, your goal is to get a perfect square trinomial, and you do that by completing the square so that you can do what you did in examples 1 and 2 by using the square root property. So here are the steps you need to take. Your first step is to get the x squared plus bx alone. Okay, that means if your problem gives you a c value, you move it to the other side. So I need to get the x squared plus 4x alone, so I need to add 12 to both sides. You don't have to write the x squared plus 4x in parentheses, I'm just showing you want to get it alone. So I have x squared plus 4x equals 12. Okay, so now you're focusing on the left side of that equation. Here's your x squared plus bx. Your next step is to complete the square. So you're getting this side to now be a trinomial that's a perfect square trinomial. So here's how I typically write it to set up. I have x squared plus 4x. I'm looking for what value do I need to add as my c value to make it a perfect square. I then still have 12 on the other side, and by rules of equations, if I add something on the left, I have to add it on the right side to keep my equation balanced. Okay, but the value that goes in each of these blanks, this is now what you did in example 3. You're finding your value of c that makes it a perfect square. So you take your b value, divide it by 2 and square it. So that would be 4 divided by 2 squared. And 4 divided by 2 is 2. 2 squared is 4. So I'm adding 4 to both sides. So it is important that you add it to the other side as well. After you complete the square, then you factor the left side. So now this problem is now like examples 1 and 2. I have a perfect square trinomial on the left side. I want to factor it as a quantity squared so I can use the square root property. So since this is a perfect square trinomial, it will factor to be a quantity squared. What quantity goes inside here? What will this be? X plus 2. So the plus 2 again is your b divided by 2. It's also the square root of 4. And then I have just 16 if I combine 12 and 4 on the right side. Okay, now you use your square root property. To solve for x, I'd have to take the square root of both sides. So I have x plus 2 equals, square root of 16 is plus or minus 4. And then to solve for x, I have to subtract 2 from each side. And again, you have 2 answers. One is going to be negative 2 plus 4. The other is negative 2 minus 4. So one of your solutions is going to be positive 2. The other is negative 6. Okay, are there any questions on 4? Some of you I know looked at number 4 and were starting to solve it by factoring. Realize that's different than solving by completing the square. Are you going to get the same answers in the end? Yes. So there are multiple ways to solve quadratic equations. I'm not saying completing the square is always the best way, but it's a method you can use. It's a method that always works because factoring does not always work, but completing the square does. We also use completing the square for more than just solving equations as well, as you'll see actually later in this chapter. So I also want to go through example 5 with you because there's one thing that's different. I'll have you do 6 on your own or in your groups, but with 5, what's different about 5 is your a value is not 1. The a value in this equation is 3. To complete the square, your a value must be 1. Completing the square does not work if your a value is not 1. So that means if you have any other value in front of x squared, your first step is you have to divide everything by it. So I have to divide everything by 3 on both sides. So yes, you're going to have fractions in this one because, for example, 2/3 and 1/3 are repeating decimals, meaning you have to leave them as fractions. So I have x squared minus 2/3 x minus 1/3 equals, and then 0 divided by 3 is still just 0. And now I go through the exact same steps we did for number 4, because now I have 1 in front of x squared. Just yes, you have fractions. So what would I have to do from here? Add 1/3. I need the 1/3 on the other side. So I have x squared minus 2/3 x. I know my next step is going to be to complete the square, so I'm going to put plus blank right away. And then equals, now I have 1/3 on the other side, plus whatever I add on the left, I have to add on the right. How am I going to find my c value here? Divide negative 2/3 by 2. Now, because negative 2/3 is already a fraction, and if I put divided by 2, I'm going to have a complex fraction. When you divide by 2, you're multiplying by 1/2. You're taking half of the number. So because I already have a fraction, I can write it as multiplied by 1/2. And then I'm still squaring it. So negative 2/3 divided by 2 or multiplied by 1/2. I can then cross cancel the 2's. And that's just negative 1/3 squared, which what is negative 1/3 squared? Leaving it as a fraction. This would be negative 1/3 times itself. How do you multiply fractions? 1/9, yeah, multiply across, so positive 1/9. So I have to add 1/9 to both sides. And then I know I'm going to simplify the right side. The left side, though, I now have a perfect square trinomial. I can factor it. It's going to be a quantity squared. So this is where knowing the shortcut, not having to do a diamond, understanding that shortcut is helpful. What goes here? How does this factor? X minus 1/3. Okay, your b divided by 2, or half of b, was negative 1/3. So in factored form, it's x minus 1/3. And then 1/3 plus 1/9 is what? 4/9. So make sure, if you're using a calculator to add fractions, great. If you're not, it's okay. You can add them not using a calculator. Make sure you have a common denominator, though. So this 1/3 would be 3/9 plus 1/9 is 4/9. Okay, we're ready then to do what? What do we do from here? Square root. So x minus 1/3 equals plus or minus, what's the square root of 4/9? 2/3. So square root of a fraction, you just take the square root of the top and the bottom. And then to solve for x, I add 1/3 to each side. So I'm going to have two solutions. One of them is going to be 1/3 plus 2/3, and the other is 1/3 minus 2/3. So we already have common denominators. 1/3 plus 2/3 is going to be 3/3, or just 1. And then 1/3 minus 2/3 is negative 1/3. Okay, so go ahead, do example 6, and I'll walk around and answer questions, make sure we understand it. Hi. How many? I have 11 or 12. Yes. Okay. Yeah. Yes. Okay. And then the timing is on 4 o'clock, right? Yeah, that's fine. Yeah. All right, I know I did not get to everybody, and I will still go over there and double check that you're all okay on that side of the room. But this way, just so you can check, this is the answer for number 6. So remember, when you have the square root of a negative number, it is imaginary. You need the I in there.